In this video, we will build an intuitive visual understanding of common network topologies. We will look at the structure, the advantages and the disadvantages of bus, star, ring, mesh, tree, and hybrid topologies, and finish with a quick comparison and how to choose the right one. 1. Bus topology. All devices tap into a single shared backbone cable. Advantages: easy to install and low cable cost for small networks. Disadvantages: a single point of failure and more collisions as you add devices. 2. Star topology. All devices connect to a central hub or switch. Advantages: easy to add or remove devices, and a cable failure affects only one device. Disadvantages: the central hub or switch is a single point of failure, and it uses more cabling than a bus. 3. Ring topology. Devices form a closed loop, each with two neighbors. Data can travel in one direction or in both directions. Advantages: predictable performance with low collisions and simple fault isolation when unidirectional. Disadvantages: a break can disable the network unless you use a dual ring, and adding or removing devices can momentarily disrupt the ring. 4. Mesh topology. Every device has direct links to many others in a full mesh to all devices or in a partial mesh to a subset. Advantages: high redundancy and alternate paths with no single point of failure in a full mesh. Disadvantages: very expensive and complex to cable and less scalable as the network grows. 5. Tree topology. A hierarchy that mixes stars connected along a backbone. Advantages: supports expansion and offers manageable fault isolation at each branch. Disadvantages: the backbone is a single point of failure and it uses more cabling than a basic star or bus. 6. Hybrid topology. A combination such as stars riding on a bus or a star of rings. Advantages: flexible and scalable, and faults can be isolated to one subtopology. Disadvantages: design and implementation are more complex and the cost can be higher due to mixed infrastructure. Let us compare these topologies side by side on cabling cost, fault tolerance, scalability, and complexity. How do you choose a topology? Consider these 4 questions. 1. Network size and growth plans. 2. Budget for cabling and hardware. 3. Required reliability and redundancy for ease of maintenance and fault isolation. Match your constraints to the strengths we just saw, and you will have a solid, practical design. If you would like real-world examples, wiring diagrams, or help selecting a topology for a specific scenario, just ask.